Okay, right. So we have seen pressure in variation of pressure with height, variation of pressure with horizontal distance also. There is no variation in pressure in horizontal line. Vertically there will be variation in pressure between this point and this point. The variation is pressure is H rho G, right? Now what? Variation of pressure in accelerated fluids. Accelerated fluids means it is not flowing actually. It is just like a beaker is there. Okay, we have taken a beaker or water bottle and we went inside the lift. We took water bottle is static. We are moving, static. Okay, then we went inside the lift. Then lift is moving up, lift is moving down. Someone felt crazy, they cut the lift, which is going down with acceleration, going up with acceleration, all those crazy things. Clear? That is what. Here not fluid is not flowing. Okay, only thing is the entire system is moving up or down. That is the story here. So case 1 is vertical. Okay, case 1 is vertical. Okay, vertical. So either it will be going up or it will be going down. So suppose if we consider fluid, if it is going upwards with some acceleration A. Clear? Now this height is H. Okay, then it will have this area. This area is A. Atmospheric pressure P naught. Okay, all these things are there. Okay, and here the pressure is P and it is moving upwards. Now consider this. If we consider a free body diagram of this, what is happening here? A is acting downwards, then mg will be acting downwards, correct or what? Then this floor will be acting PA force on that. Okay, is there any other force? Is there any other force? Which normal? This normal already we have marked. PA, mg, P naught A. This normal and this normal, even if it is there, it will be getting cancelled. Correct or what? Right. Now suppose if it is moving upwards, A. Now what is net force is equal to MA? F is equal to MA, no? One part of Newton's laws of motion. Second law is not completely F net is equal to MA. That is completely related to momentum. But we can say one part of Newton's second law is what? F net is equal to MA. So here, since it is moving upwards, upward force will be more, no? மேல போயிட்டு இருக்குது, so upward force will be more. அதுல ஏதாச்சும் சந்தேகம் இருக்குதா? இருக்கா? So PA will be more, right? PA minus P naught A plus mg will be equal to what? MA. அப்படிதானே வரும்? That is how it will happen. Correct or what? So we can write PA minus P naught A minus mg is equal to MA. So this is what is the force. Correct or what? Okay. Now what we shall write? mg can be sent to that side. Okay. So PA minus P naught A is equal to M into G plus A. M into G plus A. Okay, now what we are studying? Variation of pressure. So here this area is same, no? This area A. So PA minus P naught A is equal to, this one is area into height into density. Okay, density of the liquid, okay, into G plus A. Correct or what? Clear? Any doubt in this? Volume into density, mass is equal to volume. வேற எந்த தப்பு தவறும் செய்யல, ஒன்று மட்டும் தான் செஞ்சிருக்குது. mass is equal to volume into density. Volume is nothing but area into height, bas, nothing else. Okay, so what we are getting? The variation in pressure, the variation is pressure is what? Delta P is equal to H rho G dikku badala G plus A, bas, nothing else. If you are very strong in the basics, simply we can write H rho G effective or simply A effective. Okay, and based on different situations you can find the effective acceleration and just put. There is no change in the formula. There is no change in the formula. Correct or what? That's it. So ultimately this is nothing but P is equal to P naught plus H rho G badala G plus A. Same thing. Okay, same thing. So equation of straight line, this is how it is going to be. Correct or what? P naught H rho is the slope. Clear? If it is moving with the constant acceleration, this is how it is going to be. Clear? No change in the formula. Only thing is, if it is moving up, effective acceleration is G plus A. Any doubt? Okay, right. So now what we will do? We will reverse the direction. This upward acceleration will become downward acceleration. Correct or what? So everything is same. என்ன சேஞ்ச் பண்ணணும்? minus ma. Okay, so P naught A is acting downwards. Okay, so this time what is happening? Downward force is more. Downward force is more. Downward force is more. This means that P naught A plus mg minus PA is equal to ma. Okay, just look at the force, whichever side the acceleration is, that is the net force will be more. Fine, over. What will come? Okay, P naught A plus what is this? Area into height into rho minus PA is equal to area height into rho into A. Fine, or otherwise we'll put that side. So P naught A minus PA is equal to m into A minus G. Okay, so P naught A minus PA is equal to volume into density. So area into height into density into A minus G. So area will be cancelled off. So finally we will be getting what? Any mistake is there? P plus A mg minus PA is equal to ma. P naught A minus correct thane? P naught A mg PA. Okay, so P naught A minus PA is equal to here this side. Okay, the only difference is nothing but this we have written like a P naught minus P, that's it. So right, we will write it in the correct form, because P will be more, pressure will be more. So P minus P naught is what? H rho G minus A. So that's it. So here, instead of change in pressure G plus A, we will have what? Okay, delta P is equal to H rho G minus A, or P minus P is equal to what? P is equal to P naught plus H rho G minus A. Same thing, whatever you are studying in lift, for lift in laws of motion, no, lift is moving up, coming down with some acceleration, same thing we can apply here. There also effective acceleration will be G plus A when it is going upwards, G minus A when it is coming down. That's it. Clear or what? So this is a variation of pressure in acceleration if it is moving in the vertical direction. Okay, clear? Done. Slope P is equal to in the case this is going to be G minus A. This case it is going to be G minus A. Slope. Sorry. Okay, this is going to be rho into G plus A illana rho into G minus A. Thank you. Just correct it. Okay. So this brain fade happens. Simply we will be in the flow, we will forget. So really thank you so much. Remind me, correct the things, because some students will understand. Okay, that is a careless mistake. They will understand. Some of them may copy this down and in the evening they may spend 1 or 2 hours thinking that this is correct. Okay, there are instances like that. Okay, correct or what? So just to point out the small mistakes also in the classroom. Right, children, thank you so much. Right, clear? Shall I erase this? So next case 2. Okay, case 2 is horizontal. Okay, horizontal. Okay, so in horizontal it is nothing but, suppose if you, okay, this is full of water, this is full of water and you are accelerating in this direction. Lift na konjam discipline irukum. Idu odittu irundha, if you are running in that direction, what will happen? So suppose you take a pot of water here and hold like this and run. So water will be spilling in this direction, no? Abdiya enna sonnalum, if we are running like this, Shakuntala Dushyantan, no? Shakuntala theriyada? Okay, normal. If you are keeping a pot of water and if you are running in that direction, water will spill in which direction? Backward direction. So this thing, after spilling the water, I could draw like this. This is going to be the condition of water. Correct or what? This is the direction of acceleration. Suppose if this is the direction, if this is the pressure here, and here we will be having P naught, this length, if I consider this as L, and if this height, if I consider as H. Are you able to understand? We are moving, accelerating, going on. Okay, so water, some water spilled outside, but some water, if it is like what? Water is standing like this. Okay, acceleration is going on. Who is this? Water. Water is standing like this. Clear or what? Okay, water is standing like this. So the pressure, force will be actually in this direction. That is the reason actually this is standing like this. We will discuss this in surface tension. Whatever be the surface of water, if the surface of water is this, what is all these are water, then the direction of force will be like this. Understood or what? If water is like this, the force will be like this. If this is, okay, that is how always. So this will be the direction of force. So clear? Okay, fine. So right, fine. So one force will be in that direction, which is nothing but actually, if we do like this, actually EMG will be in this direction, and MA, which is nothing but that is also a force. That is also a force in that direction. Finally, what will happen? The net force will be in this direction when we keep acceleration in that direction. Clear or what? Okay, right? So suppose see this. If this is moving with an acceleration in that direction, have you studied about pseudo force? Have you studied about pseudo force? Okay, we can solve this without pseudo force also. If I don't want to explain all this F net, then I need not discuss about pseudo force. Without pseudo force also we can deal this. But if you don't understand, leave it. Otherwise, I could say that Newton's laws of motion is correct only in certain conditions. Okay, if the frame of reference some frame of reference, something else. Frame of reference is nothing but from where I am looking. I can look from Earth, I can look from moving car, I can look from moon. So if the frame of reference, okay, if it has got acceleration, then Newton's laws of motion cannot be applied perfectly. So what happens is that we will have to, if this is the direction of acceleration, in opposite direction we will have to put a acceleration, then only it will get correctly. See, if the resultant force is coming like this, actually mg and MA is in this direction, this should be the direction of resultant force. What we do is we will add MA in this direction and the resultant force we will mark like this. This is the resultant force. So now this is the water surface, this is the water surface. Okay, so MA is in this direction, acceleration is in this direction. We are marking MA in the opposite direction just to apply Newton's laws of motion correctly. This is the basics from laws of motion. Okay, so if you have doubt here, you should just watch pseudo force. Sir has already taken. You can watch it again and make it clear concepts if you have doubt. Okay, right? Now coming back. Okay, leave all those things. Right? Shall I erase all that? Fine. Okay, so it is moving with acceleration. Now it is moving, the water is in this way, it is coming. Now if we put an angle theta here, then we can write like a tan theta is equal to what? H divided by L. H divided by L. Okay. Okay, so this is called angle of inclination. Okay, angle of inclination. Angle of inclination. Clear? Now suppose, now if we take a water column like this, if I take a water column like this, I can consider like this. Now in this, if we apply, okay, if this is area A, this is area A, length is L, length is L. What is the force applied in this direction? P into A, correct? So force applied in this direction is what? See here, the pressure is P. Here the pressure is P naught. So I could say here the force is nothing but P naught into A. Here the force is P into A. The movement of this is, I have marked this as MA. So the acceleration is in that direction. Now in the same way, if we, this is just like a free body diagram. Any confusion in this, children? Do you have any confusion? Clear or what? All of you? Okay. Now acceleration is in that direction. Definitely PA will be more than P naught A. So F net is equal to MA PA minus P naught A is equal to MA. Correct? So PA minus P naught A is equal to what? M, what could I do? What can I substitute for M? Area into H, then rho, then A. So here A I have cancelled. Okay, so here not H, what? L. Okay, which area we are considering? Which volume we are considering? This is the column. P into this area. Okay, P naught into what mass? This area into this length, density of this liquid, not full, not H. This is area A, length this L, into rho is this liquid density into A acceleration. Yarakav doubt in this, just stop me, we'll explain again. Sudarshan Mogata Patale there konja confusion irukudunna. Correct, no? Who else is having confusion? Just looking at you only I understood. So you need not just identify pannu, you need not prolong the thing. If you get confusion, you can just show like this, hands like this. I'll explain once again peacefully. See, right from the beginning, beaker of water moving in horizontal direction with an acceleration. What will happen? Water will spill out in that direction. So what will happen? While spilling out, so much of water spilled out. Now the water will be in this shape. After standing still not. While acceleration is going on, the position of water will be like this. Number one, water height is there, pressure will be different. Here pressure nothing is there. Here this is atmosphere, pressure will be P naught, some other pressure P. This length is L, length of hinge, how much water extra is there, that is L. Now what is this angle of inclination? That is what tan theta is equal to opposite side by adjacent side. Opposite, adjacent. Done. Over. Now what we are doing is, in order to find the difference of pressure between this side and this side, always in this chapter what we do? We will take a piece of water column. Cake cut pandra mari we take, visible to our eyes. Now we are imagining water is there. Kept it there. Pressure is here. If pressure is there, pressure can make force in this direction, any direction. But what we need? The pressure between these two. So if this is an area, perpendicular pressure, force into force by area is what is pressure. So what we do? We consider the force in this direction. If this is area, force will be. So F is equal to P into A. This pressure is P naught into A. P into A is force from this side, P naught into A is force from this side. So this is moving in which direction? Acceleration in which direction? On the direction. So force towards that direction should be more, no? Then only it will move, right? So PA minus P naught A is equal to what? MA. F is equal to MA. F naught, F net is equal to MA. Effective action. Inga Bahubali. On the side, Balwa Devan, right? Both are doing. Bahubali can exert more force. Definitely he will fall down, right? So here this side, PA is more. This is Bahubali. So definitely he is going to win. This is acceleration is going in that direction. So PA minus P naught A is equal to MA. Now, which liquid column we have taken? This liquid column we have taken. This area, this length, this volume. So this mass into A, mass into acceleration is nothing but, mass is nothing but volume into density. A area into this length, that means volume of this liquid column, into rho density into A. Clear or what? Understood or what? Fine. Understood, right? So P minus P naught is our pressure difference is equal to L rho A. L rho A. So P is equal to P naught plus L rho A. Previously in vertical column, vertically acceleration due to gravity was there towards the ground. So P was P naught plus H rho G. Now this time acceleration is towards that. So P is equal to P naught plus H L A. This was H, this is L, this was G, that is A. No change in the formula. Previous going up and down, H rho G plus A or H rho G minus A. This time P naught plus L rho A. Easy, done, over. Okay, so this is moving in the opposite direction, same phenomenon. Okay, done, copied, fine. Okay, dear papas and puppies, now P is equal to what? P naught plus L rho A. P is equal to P naught plus L rho A. So simply we can say, simply what is the pressure difference here, or this pressure is equal to what? P naught plus L rho A. Okay, so P minus P naught is equal to L rho A, correct or what? P minus P naught is equal to L rho A. One more thing I could say, this P, same P, okay, is equal to, P naught is there or what? P naught plus H rho G. Can I write like that? P is equal to P naught plus H rho G. Both are same. One is, leave it. From that formula we got P is equal to P naught plus L rho A. From the other way we can say that this is P naught plus H rho G. So both are same, no? So can I write that L rho A is equal to H rho G, correct or what? Rho. Okay, so I could write H by L is equal to what? H by L is equal to, this H is in this direction. Appa G edukka koodadu. Take the other acceleration. அப்படி ஞாபகத்தில் வைக்கலாம். Otherwise what will happen? H by L is equal to G by A. We may misunderstand and in the hurry burry we will do mistake. So H by L is equal to what? A by G, my dear Tangams. H is vertical height. This is horizontal acceleration. Horizontal length. This is vertical acceleration. So H by L is equal to A by G. Lot of problems we can do just by getting these small informations. No need to do all these things. Clear? We can save time. That's it. Done? Shall I erase this? Okay, so quickly whatever we have seen, okay, we will do problem also. Before winding up the session we will do one or two problems also, but quickly let us revise, because this is difficult chapter for many. Okay, are you comfortable till now? Okay children, okay, so atmospheric pressure P naught is there. Now this is water. We are inside water. Okay, so please smile or just move, just stand up, all of you. Enna respect பண்ணிக்கோங்க, respect me, respected no? Okay, respected children, just sit down. Okay, just move no? தூங்கிட்டு இருந்தவங்க எல்லாம் முழிச்சாச்சு இல்ல? Okay, just when I was doing my entrance coaching just like you, one day what happened, friend sitting beside me, no, he just made just a sudden movement like this. Okay, a shocking movement. Then I just looked at him. I understood that he was sleeping. Then I said, what happened? Then he said, I just slept and I was seeing a dream that I am traveling on footboard of the bus, and in that dream he is falling from the footboard. That is the kind of shock we got from here. Okay, so deep dream எல்லாம் வந்து பார்க்க முடியும் கிளாஸ்ல. இவ்வளோ நிம்மதியாக தூக்கம் கிடைக்கிற வேற இடமே இருக்காது இல்லை. This is the peaceful place. We can make it an ashramam and I will become a Baba. Correct? No? Peace. When we were studying MTech, we had a chapter called SOC, System on Chip. Our specialization is making chips, no? Chips, what? Banana chips, huh? You know, all mobile, all the electronic gadgets will have some chips. So that is the thing we have done. So in that one paper is there, system on chip. Daily one of our friend, he used to read it and he used to sleep in that. Daily. Adu eduthale thookana varum. Okay, lot of technical things. Okay, so based on that, people who are very much interested on technical, they will be crazy. Right? So, okay, clear no? Right, so if this is water, here the atmospheric pressure will be there, P naught. So Balasubramaniam illa Tangam. Okay, so what is the pressure difference between this gulu and Balasubramaniam? H rho G. This is the height difference, H. This is density of water. Suppose if this is full of alcohol, rho of alcohol, then many of them will not come out of this place. Okay, H rho G, density of the fluid, height of this into G bus. What else we have studied then? Variation of pressure, horizontal, nothing is there. Okay, then acceleration, vertical motion, H rho G plus A or G minus A. Moving upwards, G plus A. Moving downwards, G minus A. Fine. Then moving left or right, what is the pressure difference? L rho A. What is angle of inclination? H by L. Tan theta is equal to H by L. Right. Then what else? Pressure difference is L rho A. Okay, then if mass comes, height and density will be compensated. If the mass is same, okay, mass is same, height and density will be compensated. Remaining all the things, height, ippudi vandalum, ippudi ponalum, what? H rho G will be vertical height, right? Fine. So comfortable till now, right? So take this problem, a cubical container, okay, a cubical container, okay, which was moving with an acceleration. Its length is L. Okay, this height is L, this is also L, because this is cubical container, right? So after moving like this, what happened? Okay, this much of the water came out of it, so we can say that half of the volume came out. Half of the volume came out. Okay, moving with an acceleration, cubical container, length is one side is L, then what happened? Half of its volume came out of the water. What is the horizontal acceleration? Option G by 2G. Okay, some options based on G. Come on. G, no? Okay, so half of the volume came out of the container means we can take like this, correct or what? So we can say, so this, suppose if this is theta, then this is H, this is L, which theta will take? Okay, if it is moving in this direction, what will happen? This is how, no? This is going to be, okay, so tan theta is equal to what? Okay, what we can do? H by L is equal to A by G. So this is L by L, A by G. So we can say that A is equal to G, correct? Clear? Okay, another question. Okay, clear or what? Done? Okay, so move with this short formula. Another question, same thing. 1/3 of the volume of water came out. Next question is, same situation, moving with an acceleration. 1/3 of water came out. 1/3 of water came out. What is the value of G? Options: A is equal to G, A is equal to 2G by 3, A is equal to 3G by 2, A is equal to என்ன சொல்லலாம் G by 2. Two G by 3, correct. 2G by 3, correct. So if we take like this, okay, So this is going to be L, this is H, theta. Okay, so how much volume is missing? Volume missing is 1/3, no? So 1/3 into L cube. 1/3 into L cube. What is the total volume? Total volume is L cube. So from this we can find it out, right? Correct or what? But all of you got this answer? Understood or what? Okay. So here, how much volume is missing? So volume missing is 1/3 L cube. Now suppose if we consider like this. So this area into this length, that is the total volume came out. Total volume we can say in two ways. One is total volume is L cube. How much water came out? L cube by 3. So water which is missing we can say in two ways. One is L cube by 3. At the same time, based on this A and this H, we can say no. That is volume missing is L cube by 3. That is one thing. Another thing is same way volume missing is equal to this area. How much is half L into H into this length is how much into L, correct? Okay, so suppose if you equate L cube by 3 is equal to L square H by 2. Okay, what we will be getting? This L cube, L square can be cancelled off. Then we can write H by L is equal to what? 2 by 3. 2 by 3. So H by L is equal, this is equal to what? A by G over, correct or what? A is equal to 2G by 3, correct or what? So in this way we can have questions from this area. Okay, now one more thing is regarding barometer. Okay, any confusion in this? Comfortable all of you? Clear? Sudarshan, Tangam, Neet, okay, no? Mukesh Auragalai, all are comfortable? Okay, right? Fine. Okay, so now there are various instruments to measure the pressure of atmosphere, atmospheric pressure, or if we have gas in a container, in order to measure that pressure of that gas. Likewise, there are various things in order to calculate the pressure. One such thing is barometer. So this barometer is to measure atmospheric pressure. So what we do is we'll take mercury. Okay, mercury. And after that we will keep a tube like this inside that. Inside that we will keep a tube. Make sure that this is vacuum. If air is there, then that will not work out. Okay, it should be vacuum. So when we do like this, what happens is, what is the pressure here? Atmospheric pressure, obviously. Whether P naught 1.01 or into 10 raised to 5 or whatever it may be. If you are keeping it at some place, whatever be the atmospheric pressure, what will happen? Here also same pressure should come. Correct or what? This whatever be the pressure here, same pressure should, this is static fluid. Horizontal level, it should be same pressure. Correct? So what will happen? This mercury will rise into this capillary tube. Okay, there will be a scale kept here. So this height will be measured. So we can say that P naught will be equal to this height, okay, into the density of mercury into G. So when someone says the pressure is 76 centimeter of mercury, when someone says like that, then we can say P is equal to 76 into 10 raised to minus 2 into 13,600 into 10. So this will be the pressure. That much will be the pressure. So based on the height of the mercury column, we will be able to say what is the atmospheric pressure. This is the idea. Why mercury we are using? Why mercury we are using? Atmospheric pressure is 1.01 into 10 raised to 5 Pascal. So H rho G will be what? 1.01 into 10 raised to 5. Now suppose if water we are using, then this is going to be 1.01 into 10 raised to 5 divided by density of water is going to be 10 raised to 3 into 10. Patak, 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 10. So how much this is going to be? Approximately 10 meter. So barometer eppadi kondu varuvandi varum? Periya truckil kondu varuvandi varum. Then we will have to call Thanos, come here, keep this instrument on sea, on the ocean side, measure the pressure. Okay, correct or what? So we thought and we had chosen a liquid with the maximum density. So mercury is having maximum, okay, densest one. So this is easy comparatively. That is the reason we are using this. Clear or what? Fine. Okay, that's it. We will do some simple problems on this and manometer, YouTube, okay, everything we will see in the next class.